Page 14. Chaos theory and the 80-20 principle illuminate each other. What have chaos theory and related scientific concepts got to do with the 80-20 principle? Although no one else appears to have made the link, I think the answer is a great deal. Let's read some deals. 1. The principle of imbalance. 2. The universe is not a straight line. 3. Feedback loops distort and disturb balance. 4. The tipping point. 5. First come, best served. The principle of imbalance. The common thread between chaos theory and the 80-20 principle is the issue of balance, or, more precisely, imbalance. Both chaos theory and the 80-20 principle assert, with a great deal of empirical backing, that the universe is unbalanced. They both say that the world is not linear, cause and effect are rarely linked in an equal way. Both also place great store by self-organization. Some forces are always more forceful than others and will try to grab more than their fair share of resources. Chaos theory helps to explain why and how this imbalance happens by tracing a number of developments over time. The universe is not a straight line. The 80-20 principle, like chaos theory, is based around the idea of non-linearity. A great deal of what happens is unimportant and can be disregarded. Yet there are always a few forces that have an influence way beyond their numbers. These are the forces that must be identified and watched. If they are forces for good, we should multiply them. If they are forces we don't like, we need to think very carefully about how to neutralize them. The 80-20 principle supplies a very powerful empirical test of nonlinearity in any system. We can ask, do 20% of causes lead to 80% of results? Is 80% of any phenomenon associated with only 20% of a related phenomenon? This is a useful method to flush out nonlinearity, but it is even more useful because it directs us to identifying the unusually powerful forces at work. Feedback loops distort and disturb balance. The 80-20 principle is also consistent with, and can be explained by a reference to, the feedback loops identified by chaos theory, whereby small initial influences can become greatly multiplied and produce highly unexpected results, which nevertheless can be explained in retrospect. In the absence of feedback loops, the natural distribution of phenomena would be 50-50, inputs of a given frequency would lead to commensurate results. If is only because of positive and negative feedback loops that causes do not have equal results. Yet it also seems to be true that powerful positive feedback loops only affect a small minority of the inputs. This helps to explain why those small minority of inputs can exert so much influence. We can see positive feedback loops operating in many areas, explaining how it is that we typically end up with 80-20 rather than 50-50 relationships between populations. For example, the rich get richer, not just, or mainly, because of superior abilities, but because riches beget riches. A similar phenomenon exists with goldfish in a pond. Even if you start with goldfish almost exactly the same size, those that are slightly bigger become very much bigger, because, even with only slight initial advantages in stronger propulsion and larger mouths, they are able to capture and gobble up disproportionate amounts of food. The tipping point. Related to the idea of feedback loops is the concept of a tipping point. Up to a certain point, a new force, whether it is a new product, a disease, a new rock group or a new social habit such as jogging or rollerblading, finds it difficult to make headway. A great deal of effort generates little by way of results. At this point many pioneers give up. But if the new force persists and can cross a certain invisible line, A small amount of additional effort can reap huge returns. This invisible line is the tipping point. The concept comes from the principles of epidemic theory. The tipping point is the point at which an ordinary and stable phenomenon, a low-level flu outbreak, can turn into a public health crisis, because of the number of people who are infected and can therefore infect others. And since the behavior of epidemics is nonlinear and they don't behave in the way we expect, small changes, like bringing new infections down to 30,000 from 40,000, can have huge effects. It all depends when and how the changes are made. First come, best served. Chaos theory advocates sensitive dependence on initial conditions. What happens first, even something ostensibly trivial, can have a disproportionate effect. This resonates with, and helps to explain, the 80-20 principle. The latter states that a minority of causes exert a majority of effects. One limitation of the 80-20 principle, taken in isolation, is that it always represents a snapshot of what is true now, or, more precisely, in the very recent past when the snapshot was taken. This is where chaos theory's doctrine of sensitive dependence on initial conditions is helpful. A small lead early on can turn into a larger lead or a dominant position later on, until equilibrium is disturbed and another small force then exerts a disproportionate influence. A firm that, in the early stages of a market, provides a product that is 10% better than its rivals may end up with 100 or 200% greater market share, even if the rivals later provide a better product. In the early days of motoring, if 51% of drivers or countries decide to drive on the right rather than the left of the road, this will tend to become the norm for nearly 100% of road users. In the early days of using a circular clock, if 51% of clocks go what we now call clockwise rather than counterclockwise, this convention will become dominant, although clocks could just as logically have moved to the left. In fact, the clock over Florence Cathedral moves counterclockwise and shows 24 hours. Soon after 1442, when the cathedral was built, the authorities and clockmakers standardized on a 12-hour, clockwise clock, because the majority of clocks had those features. Yet if 51% of clocks had ever been like the clock over Florence Cathedral, we would now be reading a 24-hour clock backwards. These observations regarding sensitive dependence on initial conditions do not exactly illustrate the 80-20 principle. The examples given involve change over time, whereas the 80-20 principle involves a static breakdown of causes at any one time. Yet there is an important link between the two. Both phenomena help to show how the universe abhors balance. In the former case, we see a natural flight away from a 50-50 split of competing phenomena. A 51-49 split is inherently unstable and tends to gravitate towards a 95-5, 99-1 or even 100-0 split. Equality ends in dominance, that is one of the messages of chaos theory. The 80-20 principle's message is different yet complementary. It tells us that, at any one point, a majority of any phenomenon will be explained or caused by a minority of the actors participating in the phenomenon. 80% of the results come from 20% of the causes. A few things are important, most are not. Page 17.